Hi, it's Karen Gregorian. In this video, I want to show how we can add visible connections to the World Wide Web. This isn't just a vague idea. I've spent the past 2 years building and testing much of what you're about to see. Let's start with a few examples. Here you can see 2 pages. The one on the left is from my site. The one on the right was loaded from another site. You can see how parts of the text are connected across the 2 documents. This functionality can be used to quote content from another document or to add comments to specific parts of it. Here's another example. In this case, I have a book in one document and the footnotes for that book in another. I use visible connections to link the 2 documents. Also notice that there are actually 2 documents on the right-hand side. The second document contains maps. Visible connections link places mentioned in the text to specific positions on the maps. Here's another example of this functionality. To try out these examples, you'll need to install my extension called Visible Connections. You might be wondering, will Visible Connections work on a mobile phone? Absolutely. Here's the concept. Mobile support isn't ready yet, but we can get an idea of what the user interface may look like by running the desktop version on a smaller screen. As you can see, you can swipe left and right to switch between pages while keeping the visible connections in view at all times. What you're seeing here is something very simple, but also something the web has never truly had. Right now, when we connect documents online, we do it with hyperlinks. A link takes you away from one page and drops you into another. The connection exists, but it's invisible. You don't see how the ideas themselves relate. You just jump. Visible connections change that. Instead of just connecting pages, you can connect the ideas inside them. A sentence here responds to a sentence there. A place in the text corresponds to a location on a map. A claim in one article is directly linked to a related argument in another. It lets the web capture not just documents, but the flow of thought between them. Now imagine a world where every idea on the web could be directly connected to others, across pages, across sites, across the entire web. Naturally, you might have some questions. If visible connections are so useful, why weren't they part of the web from the very beginning? Can we add them now? Is it even technically possible? In this video, I'll talk about the history of the World Wide Web. I'll explain how, in the 90s, we accidentally introduced a completely arbitrary limitation that prevents us from having visible connections between web pages. And I'll show you how we can overcome that limitation. Visible connections are not my idea. In fact, the concept predates the internet and belongs to Ted Nelson, a pioneer of personal computing and hypertext. He is the person who coined the term hypertext. Today, when we hear that word, we usually think of HTML pages connected by hyperlinks. But for Ted Nelson, hypertext meant something much richer. He worked on a system called Project Xanadu. That system, which was never fully released, was built around visible connections and other concepts the modern web never adopted: transclusions, built-in versioning, and a built-in royalty system with granular access to content. I'll discuss Project Xanadu in more detail in the next video. In this video, however, I'll focus only on what I call simple floating links. These links are based on different principles than the floating links proposed by Ted Nelson. Their key advantage is that they can connect to arbitrary existing web pages. There's no need to wait for websites to start cooperating. If the idea of visible connections is older than the internet, why weren't visible connections built into the web from the beginning? The web was created by Tim Berners-Lee in 1991. Later, he would mention Ted Nelson and Project Xanadu in his book. But in the end, he didn't add visible connections to the web. Was it an informed decision? Did he explore all the possibilities? Or were visible connections simply not on his radar at all? The question is, how much did he really know about Ted Nelson's project? Here is the only paragraph about Project Xanadu that Tim Berners-Lee wrote in his book, Weaving the Web. If you look at the context, shortly before that paragraph, he mentions that in 1980 he developed a web-like program for personal use and already had a larger vision of a global web. That doesn't mean he had the exact technical solution at the time, but at least the general idea of the World Wide Web was already there. And then he writes this. Basically, he lists 3 people associated with hypertext: Vannevar Bush, Ted Nelson, and Doug Engelbart. To me, it looks like this. Since he was writing a book about the history of the World Wide Web, it made sense to mention earlier figures who had worked on hypertext, so he included a short summary of Ted Nelson's project. That single paragraph does not suggest a deep understanding of the project on Tim Berners-Lee's part. And if we pay attention to the phrase, unbeknownst to me, he is basically saying that in 1980, when he already had the vision of a global web, he did not know about Ted Nelson or his project. So this is where we ended up. Instead of hypertext that looks like this, we have something that looks like this. Instead of connecting ideas, we connect pages. And in that shift, I think we lost something important. Okay, so visible connections were not included in the web from the beginning. Can we add them now? Let's try the naive approach first. Let's see if we can add visible connections directly to HTML pages. I can tell you right away it won't really work, but let's go through the exercise anyway. Here we have 2 pages and we need to draw visible connections between them. First of all, can we show 2 pages side by side? Yes. In fact, the latest version of Chrome allows you to do exactly that. Now let's say we can introduce new tags into HTML, tags that store information about connections to other pages. That information is now on the first page. It's not visible, but it's there. That means the first page has the URL of the second page. Can the first page request the second page? Only if the second page is from the same website as the first page. Otherwise, it won't work. That's because browsers don't trust code on web pages to make cross-origin requests. There is another way. Let's say we have browser process here. By the way, each page runs its code in a separate process. When the first page loads, the browser process could read it and save the information about connections. It could then load the second page. It is safe because no data from the second page would be exposed to the first page. At that point, it would be the browser process's job to draw the visible connections between the 2 pages. It could render them on its own canvas. Think of it as a sheet of glass placed between you and the pages, with the connections drawn on that sheet of glass. But the browser process would need to know the exact positions of those floating links. And every time the user scrolls the page or clicks on a floating link, the browser process would have to be notified so it can redraw everything correctly. Fortunately, there's a technique called IPC, or inter-process communication. Different processes can send messages to each other. Does this mean the authors of page 1 and page 2 would need to write special code to communicate with the browser process? No. The browser process could inject code into both pages. That injected code would collect the necessary information and send it back to the browser process. It looks like it could work. It's a bit complex since we're dealing with multiple processes, but there are no hard restrictions that would prevent us from loading the pages and drawing visible connections between them. Let's see what can go wrong. First example, what if the second page uses an unfortunate background color that makes floating links almost invisible? Second example, what if the second page has a strange layout, maybe horizontal scrolling, or sections of text placed inside containers that scroll independently? Another example, what if the page contains collapsible elements? Such elements can change the text content of the page, which will break the positioning of floating links. And consider this scenario. When a user clicks a floating link on one page, the browser sends a command to the other page to scroll to a specific position. How can we be sure that this forced scroll won't interfere with existing functionality on that page? The problem is that while this approach seems technically possible, In practice, adding visible connections to regular HTML pages would be awkward and unreliable. What makes visible connections so awkward? Two things: CSS and JavaScript. The ability to customize the styles of a page makes the page unpredictable. You never know if floating links will even look acceptable on a given design, and the presence of scripts means the content can change dynamically while you're reading it, which will mess up the positioning of floating links. Let's briefly look at the history of the World Wide Web to see when CSS and JavaScript were added to the web page. In 1989, Tim Berners-Lee proposed the World Wide Web. In 1991, he published the first website. At that time, the web was not popular. 2 years later, there were only about 100 websites. Then, in 1993, a couple of students at the University of Illinois created the first widely used graphical web browser, Mosaic. That's when the web started gaining real popularity. Those two students later left the university, founded Netscape, and turned Mosaic into Netscape Navigator. It was in Netscape that CSS and JavaScript were introduced. CSS in 1994 and JavaScript in 1995. Basically, there was a fork in the road in the early 90s that nobody noticed. Apparently, it simply did not occur to Tim Berners-Lee to add visible connections to the web. And people at Netscape were acting in reactive mode. They had just made the web popular with their browser, and users immediately began asking for custom styling and interactive features, so they quickly extended HTML with styles and scripts. They saw nothing wrong with it because none of them were even considering visible connections between web pages. As a result, everyone rushed down one path and left the other completely unexplored. What could have been done differently? From the beginning, there could have been two kinds of documents. One type focused on connectivity, with visible connections built in. The other type focused on presentation and behavior, with styles and scripts. Instead, HTML page became the place for styling and scripting, and the simpler, connection-focused document was never developed. If we want visible connections on the web today, we need to introduce that missing type of document. It would still be based on HTML, but without styles and scripts. A predictable page. A page that would look the same on all websites, and that's exactly what I propose. I call this new page HDoc, which is short for Hypertext Document. Here's a slightly silly metaphor for what I'm trying to do. Imagine this is you. One day, you look in the mirror and realize you're boring. You look like everyone else. There's nothing special about you. So, to stand out, you get a bunch of face tattoos. Now you look unique. You're no longer like everyone else. But soon, you may notice that people judge you. They hesitate to associate with you because they see you as strange. There's a trade-off between uniqueness and integration. The more unique you become, the harder it is to fit in. The image on the left represents the original HTML page, once clean and simple. That page no longer exists. Modern web pages are so focused on their unique designs, animations, and features that they can't cooperate to support visible connections. The good news is that we can reintroduce the old clean document format. We just need to give it a new name to avoid confusion. Let's call it an HDoc. Showing visible connections between these new documents would be simple. Compare that to what we would have to do to show visible connections between regular HTML pages. As we discussed, in the end, that approach wouldn't really work. With HDocs, the browser handles everything. It creates the interface, loads both documents, and displays the connections between them. All of this happens inside the browser process, and it's completely safe. HDocs don't contain any scripts, so it doesn't matter whether the documents come from the same website or from different ones. We would then have two kinds of web pages, and the web would look like this. I'm deliberately using a yin-yang image. The small circles also have meaning, but I'll explain that later. For now, focus on the large white and black halves. Think of them as the sets of all Web 1 and Web 2 pages. I consider HDocs part of Web 1 because they are static documents. Historically, Web 1.0 referred to the early, mostly read-only web, simple static pages without much interactivity. HDocs follow that same principle. But they add something new: visible connections. In that sense, they don't just revive Web 1.0, they improve on it. You could even call it Web 1.1. For simplicity, though, when comparing HDocs to regular HTML pages, I'll just use the terms Web 1 and Web 2. You may ask, when should I use an HDoc and when should I use a regular HTML page? Ask yourself what Web 1 and Web 2 actually give us. Web 2 gives us two things: custom styling and interactivity. That's why CSS and JavaScript were added to HTML, to enable custom design and dynamic behavior. Naturally, you would use a Web 2 page when you need one of those two features. For example, on landing pages, often including the home page, where custom styling is important. When do you need interactivity? When your page is essentially a web application. If you're building a social network, a marketplace, or an e-commerce site, you would continue using regular HTML pages with scripts and styles. What will Web 1 give us? Connectivity. That includes visible connections, transclusions, and other ideas first explored in Project Xanadu, which could be gradually introduced over time. When do you need visible connections? I would say on blog posts, or on what we might call connected materials. For example, a book linked to maps, footnotes, or a table of contents. Essentially, the kinds of examples I showed at the beginning of this video. Why do I call the new page hypertext document? I use the word hypertext in the original sense intended by Ted Nelson. It refers to visible connections and other features that may be added over time, not just to the fact that an HDoc contains HTML tags. And by calling it a document, I want to emphasize that it is a document, not an app. Before styles and scripts were added, the browser was simply an application, and a web page was a document. Today, the browser behaves more like an operating system that runs apps, and web pages themselves behave like apps. With the introduction of HDocs, the browser would need to operate in two different modes. For regular HTML pages, it would continue acting like an operating system. For HDocs, it would act like a simple document viewer, just an app. When the browser acts like an operating system, it allows the author to control every pixel on the page. When it acts like an app, it becomes more opinionated about the interface. For example, it would impose the same layout on all HDocs across the web. Some people may feel uncomfortable with the idea of having two types of web pages. It might seem cleaner to have only one. But ask yourself, why? There's no law of nature that says there must be only one type of web page. In fact, you could argue that we already have multiple types of web pages. It depends on how you define a web page. If we say that a web page is any document that can be viewed in a browser and can contain clickable links, then there are at least three types. The first is a regular HTML page. The second is a PDF document. The third is an SVG image. All of them can be opened in a browser, and all of them can contain links. Theoretically, you could build an entire website using only PDFs or only SVG files. Depending on your definition, there may be even more web page-like formats. The point is that browsers already support multiple document types, and new ones have been added over time. What I'm proposing, in fact, are three new document formats: HDoc, CDoc, and ConDoc. In this video, I'll focus only on HDocs. The other two have already been explained in another video on my channel and on my website. Here is an example of an HDoc. Its layout is always the same. It looks identical on any website. Let's look at the navigation panels. In the source code, the information for them is provided in XML format. For example, we see two links defined for the top panel. And here they are rendered on the page. At the bottom, we see information about 3 sections with links and a footer message. And this is how that bottom section appears on the page. The author cannot control how the navigation panels look. Their appearance is defined by the browser or the client app. You can also see that a link for comments is provided in the source code. This allows comments to be loaded with a separate request. Here they are displayed on the right. Let me show another example with more comments. These comments are rendered by the client app, not styled by the website author. This makes the layout predictable. We can even switch themes, and the change will apply to everything: content, navigation panels, and the comments section. Now let me explain how I arrived at the HDoc format, so it doesn't feel arbitrary. The idea was simple: start with a regular HTML document and gradually modify it so that it no longer supports styles and scripts, but does support visible connections. The first step is to change the name of the format from HTML to HDoc. Most pages have navigation panels: top, bottom, side. We cannot allow authors to build them with custom styles because that would make the layout unpredictable, which is exactly what we want to avoid. So instead, we introduce a structured XML section where the author can provide information such as the site name and a list of links. In this example, we only have a top panel. Now that we have a panels section, a problem appears. People familiar with HTML format would expect the body tag to contain all visible elements, but now we have visible panels outside of the body. To avoid confusion, we rename the body tag. It becomes content. It can still contain HTML. Optionally, it can contain plain text. You just need to specify content type in the special attribute. Next, we add a header section. It contains the title and other visible metadata, such as the author's name and publication date. Additional fields can be added later. We keep this information separate from the main content. Why? Because if it were inside the content section and later changed, it would shift the positions of the text and potentially break floating links. It's not a big deal because links use hashes to find their new positions and most of the time won't appear broken. But still, it's best to keep this information out of the content section. You may have noticed that in the header and panels sections, I use some tags that look like HTML tags. A for links, and H1 for visible header. Those are XML tags, not HTML. For example, H1 header can contain only text, no HTML. Elements are allowed. Was it a mistake to copy the syntax from HTML tags? I don't know, but that's what I did. Okay, now we have similar looking tags, head and header. This could be confusing, so we rename head to metadata. Finally, we add a connections section. I have a page on my site explaining connections format, so I'm not going to go into details here. But you need to know one thing. The changes in content may break the floating links. However, because floating links use hashes, they usually can find their new positions in text, or at least visually show that they are broken. And this is what the source code of a typical HDoc looks like. Now let's return to the idea that all HDocs look the same everywhere. That may sound strange. But are there similar examples on today's web? I can think of two. The first example is RSS feeds. Many websites have a special endpoint that provides an RSS feed. Here is what it looks like on my site. The format of the data is XML with a list of HTML pages. If I open that feed in a reader, I see clean, nicely formatted entries. They contain only content, without navigation or site-specific design. Pages from different websites look the same in the feed reader. And I can change the theme. Notice that when the theme changes, not only colors and fonts change, the layout of additional information, like the author name or publication date, changes as well. HDocs would behave in a similar way. The difference is that they would be viewed directly in the browser and would include navigation panels. Second example is social networks. We used to surf the web. Now, many people spend their time scrolling through social media. Instead of publishing on their own sites, they post on platforms where they don't control the design, colors, fonts, layout. All of that is decided for them. They provide only the content. We've been living with this standardized presentation model for years, and nobody seems to mind. If most blog posts were published as HDocs, the web might start to feel like a social network. So what? You give up custom design that is not even needed on the vast majority of pages, and in return, you get visible connections which are actually useful. And you'll be able to choose what the web looks like for you. Currently, in my extension, you can choose between 3 different themes, but I'm sure there will be many more. Right now, they mostly differ in colors, but in the future, they could have completely different layouts, and there will be standalone apps that will allow you to deal with HDocs in new ways. In my app, LZ Desktop, you can collect them on a large canvas and connect them together. This is useful if you want to work with visible connections without publishing anything on a website. Apps and themes may present HDocs in unusual ways. Even something like this will be possible. These examples are from some demo of Project Xanadu. Apps and browsers would only need to agree on how to parse an HDoc. After that, they could present it however they like. In the end, it would be up to the users to decide what the web looks like for them. Besides standalone HDocs, there's another format, a hybrid page, what I call an embedded HDoc. Let's see how it works. I can open any page on my site, and it appears as an HDoc that can contain visible connections. If I close the reader, though, the page now looks like a normal HTML page, and the visible connections are gone. If I open the source code and look for HDoc, I find 2 things. First is the class name, HDoc content, added to the element that contains the text of the article. The second is a JSON object with the ID of HDoc data. It contains all the information needed to create an HDoc locally, apart from the actual content of the page. These additions are invisible to the users and will also be ignored by the search engines. So it's as if nothing really changed on the page. But people who use Visible Connections Chrome extension will see this page as an HDoc. Going back to the analogy I used earlier, if the clean-faced person represents an HDoc and the tattooed person represents a regular HTML page, then the embedded HDoc is somewhere in between. With the right software, it looks like an HDoc. Without it, it looks like a standard HTML page. When should you use an embedded HDoc instead of a standalone HDoc? It depends on whether visible connections are optional for that page. For example, I uploaded a book by Herodotus to my server and connected it to 2 other documents using visible connections. In that case, I used a standalone HDoc. If I disable the reader, the page appears broken because the browser doesn't know how to render it properly. But in this case, the entire purpose of uploading the book was to demonstrate visible connections. If someone simply wants to read the book, they can find it elsewhere on the web. I've added a message explaining what users need to do to view the document correctly. If they choose not to install the extension and the page looks broken to them, that's fine with me. With my blog posts, however, the situation is different. I want them to look good even if the user doesn't have the extension installed. I also want them to be properly indexed by search engines. So for blog posts, I use the embedded HDoc format. I still encourage readers to install the extension to see visible connections. If they don't, they won't see the connections, but they will still see a normal, properly formatted web page. By the way, if you have a WordPress website, you can make every page support embedded HDocs by installing my plugin called Static Web Publisher. There will likely be plugins for other content management systems in the future. So what's the plan for adding visible connections to the World Wide Web? Imagine the web as a cloud of resources. The red dots represent HTML pages. And this crowd of people represents everyone who uses a browser, about 5 to 6 billion people. All of them use their browsers to view HTML documents. Then, I built a browser extension. That's me. And this is my browser with the extension installed. The extension allows me to view HDocs. Right now, there are only a few HDocs on the web. I created them. The next step is to make the extension popular and significantly increase the number of HDocs. They should appear on many different websites. Ideally, we want to grow the user base to millions. Is that realistic? I hope so. Later in this video, I'll talk about some use cases so you can decide for yourself whether that's possible. For now, let's assume we reach a point where millions of people are using the extension and many websites are publishing content with visible connections. When that happens, the next logical step is for browsers to support visible connections natively. After that, the extension will no longer be necessary. Eventually, hybrid pages that function both as HTML and as HDocs could be replaced with standalone HDocs. This strategy has worked before. Several features that are now built into browsers originally appeared as plugins. For example, rendering mathematical formulas once required a plugin because browsers couldn't handle them properly. The same was true for PDF documents. For years, you needed a plugin to view a PDF in your browser. Today, instead of plugins, we use browser extensions, but the principle is the same. If you want to introduce new functionality to the World Wide Web, starting with a browser extension makes the most sense. Now let's briefly return to the yin-yang image and look at what the small circles represent. The black circle stands for Web 2 inside Web 1. In practical terms, this means you can use iframes inside an HDoc. If you need additional functionality, you can embed it through an iframe. For example, I use iframes to include YouTube videos. It's also possible to place a special iframe in the side panel. In the future, I plan to add one below the comments section so users can submit comments directly. At the moment, if you want to leave a comment, you have to close the reader, switch back to the HTML version of the page, and submit your comment there. An embedded iframe would eliminate that extra step and make HDocs more practical. The white circle represents Web 1 inside Web 2. This hasn't been implemented yet, but here's what it could look like. There's a category of apps often called readers. Apps that let you save web pages in a clean format and sync them across devices. Examples include Instapaper and Readwise Reader. One day, such apps could start recognizing HDocs. When you save an HDoc in the app, the documents it connects to could be saved along with the main document. Then, when you open it later, the app could display it side by side with the connected documents and render the visible connections. This would work because the app serves both documents from its own server, even if they originally came from different websites. In that case, cross-domain restrictions would not apply. The app would only need to implement the user interface for visible connections. A browser extension wouldn't help here. Another scenario. Suppose you want to have HDocs that are accessible only to authenticated users within your organization. The most straightforward solution would be to build a website that hosts all those documents and renders visible connections between them. It will handle authenticated requests. And again, it will work because all documents come from the same server, so the web page can show two documents side by side. At that point, the documents wouldn't even need to be HDocs. They could use any internal format. So Web 1 inside Web 2 simply means that a website or app can be programmed to display visible connections in its own environment. It can use HDocs or any other document type. The only real limitation is that the documents must be served from the same server. There's one more thing I want to show while we're here. Suppose we have two HDocs. Connecting one HDoc to another is straightforward. You simply provide the URL of the second document. However, if you want to connect an HDoc to a regular HTML page, you also need to define parsing rules. Parsing rules are one or more selectors added to the URL of a connected document. I explained them in the previous video, so I won't go into detail here, but a few important points are worth mentioning. Parsing rules won't help if the target page cannot be downloaded as a standard HTML document and is instead constructed programmatically in the browser. A good example is posts on X, formerly Twitter. Those posts are delivered as JSON data, which is then used to generate HTML locally in the browser. Another challenging case is a site with non-human readable class names, where creating reliable parsing rules becomes difficult, as with articles on Medium. That said, in most cases, especially with typical blog posts, parsing rules work perfectly well. You could think of parsing rules as a bit of a hack, since they rely on the UI layer to extract content. If a website changes its theme, for example, the connected page may appear broken. In that case, the parsing rules would need to be updated. Here's how I see it. First, parsing rules are currently the only practical way to connect to the millions of pages that already exist on the web. Second, yes, they're imperfect. But that's the price we pay for creating a web architecture that doesn't allow visible connections between pages. Third, this is temporary. If a page that was previously connected through parsing rules later becomes an HDoc, then the next time you open it as a secondary document, the parsing rules will be ignored. It will render according to the structured data provided by the HDoc itself. Over time, as more and more pages adopt the new format, the need for parsing rules will gradually diminish. In an ideal scenario, Web 2 would primarily consist of landing pages and web applications, the kinds of pages where visible connections aren't particularly useful anyway. Meanwhile, content-driven pages, such as articles and blog posts, would be formatted as HDocs and would no longer require parsing rules to form connections. Let's take a look at the current state of the project and the software we have so far. On the back end, we have the Static Web Publisher plugin. It's a WordPress plugin, and it adds support for visible connections to posts and pages on your website. WordPress powers around 40% of all websites on the internet, so that gives us solid coverage right away. As for other content management systems like Joomla, Drupal, and others, we don't have plugins for them yet. And to be honest, developing those is not a priority. I would only look into it if there's strong demand. And let's not forget, you can always upload an HDoc as a file using your file manager. That works on any website, no plugin required. So on the back end, I'd say we're in pretty good shape. On the front end, we have the Visible Connections Chrome extension. That doesn't mean it only works in Chrome. It works in any Chromium-based browser, like Opera, Edge, and others. You can run it on Android, but only in a few browsers that support extensions. And even then, you're basically looking at a desktop layout squeezed onto a small screen. In the future, I'll need to properly optimize the extension for Android so it looks good on mobile devices. After that, it will need to be ported to iOS as a Safari extension, and that part will be a bit more tricky. So on the front end, coverage is still limited. We're starting with desktop, and proper mobile support will come later. There's also a desktop app I developed called LZ Desktop. It can be useful for creating image collages and for working with a large number of visible connections. You can create visible connections using only the browser extension. But when you're dealing with many floating links, it can be much more convenient to use the app. It's also useful if you want to create connections just for yourself. With the app, you don't have to publish anything on your website in order to use them. Right now, the app is available for Windows and macOS. If there's enough demand, I may release a Linux version in the future. What's next? If you like the idea of adding visible connections to the World Wide Web, we need to work together to make the Visible Connections Chrome extension popular. The simplest thing you can do is install the extension and keep it installed. Right now, the extension might not feel very useful because there isn't much content with visible connections yet. Think of installing it as casting a vote. Keeping it installed shows that this is a feature worth building into the web. Beyond installing the extension, you can help by spreading the word. Share this video. Tell your friends. Start conversations about what Visible Connections could do for the web. You can also create content with Visible Connections. There's a video on my channel that shows exactly how. And this part is important. Visible connections only become meaningful when people actually start using them. The idea needs real examples, spread across different websites. Once you publish something, send it to me. I'd love to feature it. I've set up a community resources page where I'll link materials from other sites. Right now, the bar for what counts as interesting is intentionally low. What matters is showing that this feature is being used on multiple websites. When you publish Visible Connections, don't hesitate to include a link to the extension on your page. You don't have to add it everywhere, but it makes sense to place it on pages that actually use Visible Connections. If you are concerned about SEO, add a rel attribute with the value of nofollow to the link. By linking to the extension, you're not promoting anything shady. There's no hidden business model behind it. After all, the ultimate goal of the extension is to become obsolete. Once browsers support Visible Connections natively, the extension simply won't be needed anymore. And the extension is open source. Anyone can look at the code and see exactly what it does under the hood. How long will it take for browsers to support Visible Connections natively? It could take a while. PDF support, for example, took nearly 2 decades to become standard across all major browsers. Hopefully, Visible Connections will be adopted faster. Will this work? I don't know, but I am completely convinced that the web needs Visible Connections. Whether others will see it the same way? We'll find out. Either way, it's worth trying. This is how I personally plan to promote Visible Connections. As we discussed earlier, Visible Connections let us link ideas, not just pages. When promoting Visible Connections, my initial focus will likely be educators. Teachers can create learning materials that use Visible Connections to help students explore content non-linearly, see relationships between concepts, and think more structurally. For example, a history lesson could link text directly to maps, letting students trace events geographically while reading. Students can follow a sentence here to a related point there, or trace an idea across multiple documents, turning the web into an interactive classroom. Teachers are ideal early adopters because they can integrate the extension into their lessons and show students its value. This can help grow the user base quickly, potentially to millions, just through education. But to make Visible Connections truly widespread, we also need to reach bloggers. On blogs and other everyday sites, Visible Connections can be used casually, linking a single idea in one post to a related point elsewhere. Bloggers can help take this feature beyond classrooms, making it relevant to anyone reading or publishing online. They are key to moving Visible Connections from a niche tool into something mainstream. A personal note: if progress seems slow, don't assume the project has been abandoned. I took a sabbatical to build this, even though it was financially risky, because I believe the idea is worth it. Right now, unless I secure funding soon, I may need to pause active development and promotion to stabilize my finances. For now, my main goal is simply to bring the idea into the open. I don't want to keep it hidden just because I may temporarily lack the resources to keep actively working on the project. That's why I made this video. I want to share the vision publicly and see if others believe it's worth building together. If you found this interesting, like the video and subscribe to the channel. You can also visit my website, check the contact information, and follow me on social media to stay updated on the project. Thanks for watching.